أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Exercise 1.2, question number 5. z1 plus z2 mod square minus z1 minus z2 mod square is equal to 4 real z1 real z2. First of all, let z1 complex number which is equal to x plus iota y1 and z2 complex number equal to x2 plus iota y2. Putting the value of z1 and z2 in above equation, x1 plus iota y1, x2 plus iota y2 minus sign z1 x1 plus iota y1 minus sign x1 plus iota y1 magnitude scalar. Now we are separating real and imaginary parts. Here real parts x1 plus x2 plus iota, imaginary parts y1 plus y2. Magnitude square minus x1 minus x2 real part plus iota y1 minus y2 imaginary part magnitude whole square. Now taking mod, real part square plus sign and imaginary part square. Same is the case here, minus sign as such, real part square plus imaginary part square. As we are taking mod, so square cancel with square root. Same is the case here, no opening square. First term square x1 square, second term square x2 square plus 2x1 x2. Similarly y1 square plus y2 square plus 2y1 y2 minus sign as such, opening square this x1 square plus x2 square minus 2x1 x2, opening this square plus y1 square plus y2 square minus 2y1 y2. No, x1 square cancel minus x1 square, x2 square cancel with minus plus minus minus x2 square. Similarly y1 and y2 square cancel with minus y1 and y2 square. As this sign change all the sign within brackets, so these are cancelled, and 2x1 x2 here minus minus 2 and 2 4x1 x2. Similarly 2y1 y2 here minus minus plus 2 4 4y1 y2. We can write taking 4 common, 4 into x1 x2 plus y1 y2. So here x1 and x2 is the real part, and x1 is the real part of z1 and x2 is the real part of z2, which is equal to right hand side, hence proved. Question number 6. Find the value of lambda given that z1 over z2 plus lambda bar is equal to lambda plus 2 square root. Here given is z1 is equal to 3 plus iota and z2 is equal to 1 plus iota. Putting the value of z1 and z2, z1 is 3 plus iota over 1, z2 1 plus iota plus lambda mod is equal to lambda plus 2. Now we're dividing and multiply with its 1 plus iota conjugate, which is 1 minus iota, multiplying and dividing it, plus lambda as such is equal to lambda plus 2 as such. Now multiplying 3 plus iota with 1 minus iota, first of all multiply 3 with 1 minus iota, 3 into 1 3, 3 into minus iota minus 3 iota. Now iota with 1 minus iota, iota into 1 iota plus minus minus iota square over 1 plus iota into 1 minus iota, a plus b into a minus b is equal to a square minus b square. So 1 square minus iota square plus lambda mod is equal to lambda plus 2. Now 3 iota square value, as we know that minus 1 into minus plus 1 or plus 3 4 minus 3 iota plus iota minus 2 iota over iota square value minus 1 minus plus 2 and plus lambda is equal to lambda plus 2 square root. Taking 2 common and cancel with 2, here remains 2 minus iota plus lambda is equal to lambda plus 2. Now taking mod, real part square plus imaginary part square, real part 2 plus lambda, imaginary part 1 minus 1, so taking its square, right hand side remains as such. Now opening squares is becomes lambda square plus 4 plus 4 lambda plus 1 is equal to lambda plus 2 square root. Taking square on both sides, it becomes lambda square 4 plus 1 5 plus 4 lambda, here lambda positive it becomes negative here, plus 2 comes here and becomes negative. So lambda square 4 lambda minus lambda 3 lambda 5 minus 2 plus 3 equal to 0. Here we apply quadratic equation to find the value of lambda. Lambda is equal to minus b value 3 minus 3, b value square which is 3 square minus 4 a value 1 and c value 3, 4ac over 2a, 2 into a value 1. Now we solve it. Minus 3 square 9, 4 3 12 over 2. Minus 3 plus minus 3 square root over 2, and we know that minus 1 square root equal to iota, so we can write it as form minus 3 plus minus iota 3 square root over 2. Exercise 1.2, question number 7. 2 square root into z mod greater than or equal to real z mod plus imaginary z mod. In this question, hint is given, which is start with x magnitude minus y magnitude y mod whole square greater than or equal to 0. Hint is given, so we use this hint: x magnitude minus y magnitude whole square greater than or equal to 0. Opening the square, x magnitude square plus a square plus b mean y magnitude square minus 2ab minus 2 x magnitude into y magnitude greater or equal to 0. As x magnitude square is equal to x square and y magnitude square is equal to y square, so x square plus y square minus 2x magnitude into y magnitude greater or equal to 0. Now x square comma y square, we take it in other side of inequality. It becomes positive 2x magnitude into y magnitude, adding x square plus y square on both sides. X square plus y square, x square plus y square greater or equal to x square plus y square plus 2x into 2x magnitude into y magnitude. It becomes 2x square plus 2y square greater or equal to, it becomes x magnitude plus y magnitude whole square, as x square is equal to x magnitude square and y square is equal to y mod magnitude square. So it becomes x plus y, x magnitude x mod plus y mod whole square. So taking square root on both sides, it becomes 2x square plus 2y square square root greater or equal to x plus y, x mod plus y mod whole square square roots. Square cancel with square root. Here 2, taking 2 common, which becomes 2 square root. Here remains x square plus y square square root. No, greater or equal to x magnitude plus y magnitude. 2 square root remains as such, as it is value of z mod, so we write it here, and x magnitude is the real part of z magnitude and y magnitude is the imaginary of z magnitude. Here comes magnitude, which is equal to right hand side. Question number 8. Write equations in xy form by taking z is equal to x plus iota y. Question is 2z minus iota mod is equal to 4. Putting the value of z 2 into x plus iota y minus iota mod is equal to 4. Separating real and imaginary parts, 2x real part, 2 iota y minus iota taking common, 2y minus 1 mod is equal to 0. Taking mod, real part square plus imaginary part square equal to square root equal to 4. Now 2x taking square on both sides, square cancel with square root and 4 square 16. Remains 2x square plus 2y minus 1 whole square is equal to 16. Now opening square, 2x square 4x square plus a term square 4y square plus b term square 1 minus 2ab becomes 4y equal to 16. Here 4x square plus 4y square minus 4y is equal to 15 plus 1. Here minus 1, 16 minus 1 equal to 15. Now x square y square, x square plus y square minus y is equal to 15 by 4. Now adding 1 by 4 on both sides to complete this square. Now adding 1 by 4 on both sides. So y square minus y plus 1 by 4 equal to y minus 1 by 2 whole square. When we open this square, it becomes y square minus 4 minus y plus 1 by 4. So here it becomes 16 by 4 is equal to 4. X square plus y minus 1 by 2 whole square is equal to 4. It convert in xy form. Now we solve part number 2, which is equal to z minus 1 mod is equal to z conjugate plus iota mod. Putting the value of z, x plus iota y minus 1 mod is equal to x minus iota y. Z mod becomes x minus iota y plus iota mod. Now separating real and imaginary parts, x minus 1 real part, iota y imaginary part. Same is the case is here, real part and y minus 1 is imaginary part. Taking minus iota common, it becomes y minus plus minus 1. Now taking mod, real part square plus imaginary part square. Here real part x square, imaginary part y minus 1. Now taking square on both sides, square cancel with square out. It becomes x minus 1 whole square plus y square is equal to x square plus y minus 1 whole square. Opening square, it becomes x square plus 1 minus 2x plus y square equal to x square plus a term square plus b term square minus 2ab. Okay, x square cancel with x square, 1 cancel with 1 and y square cancel with y square. Remains minus 2x is equal to minus 2y, minus 2 cancel with minus 2, it becomes x is equal to y, which is the answer.